Hi, I'm Leif from Leif Labs, and this video is going to show you how to make these shapes as presented in earlier videos if you don't have access to a printer and you can't trace the shapes. So I'm going to do this using a protractor because protractors, while they're not really my favorite tool for geometry, they're relatively easy to buy. And you can find them often in the school supply section of sort of ordinary stores like CVS or something. So what a protractor is a device that measures out angles. So I can see all these angles. I go from 0 to 90 one side, 0 to 90 on the other side, 180 degrees. So if I want to make a square, I'm going to make a dot, and then I'm going to make a dot at 90 degrees and 0 degrees. And then I'm going to move over so that the dot, I have one dot in the center and one dot here, and I'm going to complete the square. Then I can draw lines between all of these to make a square. Now if I want to fill the square in with this kind of fractal, what I can do is take the thing and fold it down the middle. I can actually make two of these squares. Use one as a sort of a sacrificial square. Fold it down the middle, and then again and again and again, and then use those folded in half sections to measure out correctly to get your half, quarter, eighth, and so on to get this kind of square fractal that we use for measuring and so on. So then, if I want to make this one, I take the square that I just made, replicate that again, and then I'm going to just connect, using a ruler, I can connect diagonally across here to make that. Now, if I have that and I have a square and I want to make all of these lines, then I can use the square to draw this line down the middle, and then do it again and again and again and again. And so when you see, in order to draw this fractal, to get this pattern here, which is important for a lot of other constructions we're going to do, all I have to do is use a right angle here, and then a right angle there, a right angle there, right angle, and so on. So you make as many of these as you want, color them in, cut them out, laminate them, and that's your first two shapes. Now, for this one, I'm going to do the same thing, but I'm going to use a 60-degree angle. So I'm going to draw a dot, draw another dot, and then I'm going to go to 60/120, which is here, and I'm going to draw complete the triangle here. And then if I make the triangle the same side length as the square, then I can use my square to measure off the halfway point on 1, 2, and 3 of these. There's my triangle. I connect the dots, color it in, laminate it, cut it out. So there are our first three shapes: square, isosceles right, and equilateral. The next shapes that we're going to do are going to be the pair that get us the pentagon and five-fold symmetry. This is the golden triangle and the golden gnomon. And what I'm going to do is I'm going to make a golden triangle first, which is going to be, there's a number of ways that I could do this, but I'm going to do it, so I'm going to draw a dot here, I'm going to draw a dot here, and then I'm going to go up to 36 degrees. So that's going to be here. There's 36 degrees. I go like this, like that, and then I complete the bottom of the triangle. Just to compare, yes, that is the right angle. That's the right angle. That's 72 degrees. Boom. So there it is. Now, if I want to make the other one, how do I do that? Well, there's a number of ways to do it, but probably the easiest way is actually just to take, I'm going to make this and I'm going to cut it out, I'm going to finish it. And in order to finish the interior of this, I can make two and then use one to go in and make this inner fractal to get the golden ratio scaling. So I do this repeatedly and then go boom, 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 boom down here, color it in, and then I get this triangle. So now, if I want to make the golden gnomon that goes with this, what I'm going to do is use my triangle. It doesn't even have to be the same size triangle, it doesn't matter. I go up here and I draw a line. It's longer than it needs to be. It's fine. Because then I'm going to go on the other side and I'm going to draw another line. And boom, this is now the triangle that I want. And so if I'm going to make it like this, I'm going to color, I'm going to make this kind of fractal pattern. So again, this shows the self-replicating nature of this, and that I can make this triangle and then I make a second one by using the first one to get all the angles right for the second one. Now I can use either one of them to then complete and make this other triangle, which I then cut out, color in, and laminate. So these are the two triangles that together make the pentagon. Now there are two remaining triangles, and these are the two triangles that get us the parts of the hexagon. This is how a hexagon is put together, is with these two triangles. So the first of these triangles, and I'm generally going to make these so that you can see there's this one side that remains constant on all of the different shapes that's the same. So it's the side of the ones that are the same all the way around is also the same as the side that's the longer of the two parts of the right part of this triangle, and then also the longer of this isosceles triangle. So I'll start by making this triangle a 30, 60, 90 right triangle. So I'm going to make a 30-degree angle. Draw a dot, draw a dot. I'm going to go up 1, 10, 20, 30, and like that. So now I can draw this line like this. I can draw this line segment like this. So this sets the distance, is this distance right here. And now I want to make this vertical. So I can use one of my things that has a right angle in it. I can use either one of these, doesn't matter. And I use the right angle to complete this. So this is the 30, 60, 90. Now the other thing about the 30, 60, 90 right triangle is that you can construct them if you buy a protractor. It often comes with one of these. And so then you can just use this to trace it out. So having made that, I want to make this other isosceles triangle that mates to this. So to do that, I can once again do the thing where I make a second one of these. So I cut this out, get it actually ready to use, and then I can get a 30-degree angle by using this like this. I draw it longer than it needs to be, which is fine. And then I go on the other side and draw it longer than it needs to be. And there's the other triangle. So in order to fill in this fractal, that this kind of like square root of 3 fractal that's here, I'm going to take this and complete that. And so on. So I do this for whatever size triangle I choose to make. I'm going to decide how far into this I want to go, how detailed I want to be, color it in, laminate, and cut it out. And then the same thing with this. So for this, the way that these triangles work is, again, they go down by this factor of the square root of 3. So I'm going to use 30 degrees like this, go like that, like that, okay, and then I'm going to do 30 degrees. I'm also going to make a right angle here. You can see how easy it is to replicate these. Once you start to get some shapes, it's easy to make more shapes with the shapes that you have. This is the power of self-replicating media, is that, you know, it does replicate very easily. So it goes like this, boom, 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 boom. I can make that fractal. So that, if I cut all these out and laminate them, then I get these shapes again. And so this is how you can go from a protractor to all of these shapes. So if you don't have access to a printer and you find tracing off of a screen to be annoying and you don't want to use classical constructions, this is a tool that you can buy at a lot of stores because it's often required that students buy it in school. So if you go to a place where there's school supplies, you can often find this. Protractor, get it, use it, or don't. Again, I'm not a huge fan of the protractor, but this is how you use it. So thank you for listening, like and subscribe.